Hey guys, we're here to learn today a little bit more about the process of fermentation and esterification. We're here with Steve, an undergraduate researcher. Steve, can you tell us a little bit about fermentation?
Sure. Well, here we are in front of corn, and corn can be used as a feedstock in fermentation, where the yeast and other bacteria convert cellulose from the corn into carbon dioxide and alcohols, so like ethanol. Ethanol can be directly added to fuels such as gasoline and biodiesel.
Great, and what's some of the problems with using corn as a feedstock?
Well, as you know, corn is in a lot of different food products, and there being only so much farmland to go around, corn that gets used for fuel can't be used for food. So we'd like to try to find a way to turn non-food products into energy, and that's where pyrolysis comes in.
But like fermentation, pyrolysis isn't perfect. There are big, heavy compounds that gunk up transfer line called tars. Also, there are a lot of different operating conditions and catalysts you can use, so those need to be optimized as well. And finally, you don't quite know what you're going to get from different biomasses. There could be a wide range of product distributions. Let's go check it out in the lab. Hey Josh.
Hey Dave, welcome back to the lab. I was hoping you could take a couple minutes and tell us what some of the problems are with trying to convert biomass into energy.
So Josh, one of the biggest problems with converting biomass is the presence of tars. Tars are big, heavy hydrocarbons that, boil at a very high temperature. So they gunk up lines and they deactivate catalysts.
What do the tars look like?
So Josh, tars are big, heavy hydrocarbons. They look kind of like this. They're carbon rings with double bonds in the middle. They're called aromatic rings. In real life, tars are black and sticky. So here's a fresh sample. And here's a tarred sample. Now, if we go over to the spouted bed, I'll show you some of the other problems we've been having. One of the biggest things you need when you're scaling up is consistency. You need to make sure you get the same products today and a year from now. So you need to make sure you have a good, consistent source of biomass.
What are some examples of getting inconsistent results?
So if you see here, we have a chromatogram of algae, and there are a lot of lower boiling compounds. But if you look at this chromatogram of miscanthus, you can see that there's a much wider distribution of compounds. Each peak on the chromatograph represents a different compound, and the area under the curve represents how much of that compound there is. We run into the same problems with the gasifier. These are gasifier tars, and they build up inside the gasifier. They're chunky and they come apart pretty easy. They're mostly made of carbon too.